Alanna Mitchell is a journalist. She has actually been called the world's best environmental journalist. She writes on topics relating to science and society, and Alanna started her journalism career at Canada's The Financial Post, where she won many awards for her investigative journalism. Through her investigation of less than ethical behavior in banking and business practices. After 3 years, she went to the Globe and Mail and wrote on social trends and statistics. And at the Globe, she also won many major national and international awards. One year, in 2008, she won the Atkinson Fellowship in Journalism Award, and you might have seen some of her articles in the Globe and Mail. She's the author of several books, and she's won a prestigious U.S. Grantham Prize for her book, Seasick: The Global Ocean in Crisis. She is a freelance journalist for many magazines and newspapers like the New York Times, where she contributes her outstanding blend of storytelling and investigative journalism in their section on science. She has written for our own United Church Observer on many topics, and if you get the Observer, you may have seen some of her articles in our church magazine. She is a member of the United Church of Canada. She's a regular contributor on CBC's Quarks and Quirks, as well as she writes and contributes to numerous TV and radio documentaries for the CBC. She's an author and now a playwright. Of her most recent full-length book, Seasick, she has written a play, and it is an award-winning international best-selling book, and I'm sure her playwright and acting debut will get just as many awards. Her one-woman play, based on this book, is touring Canada and will next appear October 29th to November the 2nd at the Theatre Centre in Toronto, which is on Queen Street West, and tickets are on sale now. On a personal note, several years ago I had the privilege of attending a dinner party arranged by a mutual friend where Alanna and her husband Jim provided some very excellent conversation, and she encouraged me as I was embarking on my own notion of writing a biography on a living woman, Lois Wilson. And I thank her very much for her support and encouragement of that project and that lifelong undertaking, it seemed. I have read her book, Seasick: A Global Ocean in Crisis, and I've told Alanna that I loved it and I hated it. I loved it because it was easy to read. She's a magnificent writer and breaks down such complex topics and notions and the interconnectedness of our oceans into understandable bites. I hated it because of what she had to tell us. However, there was hope in her message in her book, and she is here this morning to share that with us. Her book, both books, will also be available at the kiosk. There's a table set up after the service, and Alanna will be there to sign your copy if you choose to buy it. Buy it for family and friends. Christmas is coming, and it's an excellent read and well worth understanding what is actually happening to life in the sea and life and our life in connection with it. So Alanna has also generously offered that with every sale of the book this morning, some of the proceeds of that will go to West Hill United Church as a fundraiser. So I thank her very much for that on behalf of West Hill. Alanna, I am delighted that you are here this morning, and I welcome you and turn it over to you.
Thank you, Janice. Actually, at that dinner with Janice explained to me that Lois Wilson likes to go canoeing and that she loves to skinny dip when she canoes, and that all with women her own age. And so it became my fate to do a documentary for Tapestry on CBC Radio about a journey I went on with Lois Wilson, the youngest at 50. Then I was youngest by a couple of, 3 or 4 decades of all the women. And I'm here with my tape recorder taping as these rather elderly women are skinny dipping up in up in Lake Superior. It was a journey. So I thank you for that. I would never have known. Who would know, right? It's just a great joy to be here. Thank you very much for inviting me. Thank you, Karen Cormier, for inviting me, and Janice, and thank you, Deb, for reading my words. You make me sound like a poet. So I'm, as you know, I'm a journalist, so I'm here to tell you some stories because that's what I do for a living. And sometimes I write books too, but what it means is that I'm pretty interested in finding stuff out, and not only just finding stuff out, but in democratizing the information. So I'm not so much a polemicist as I am an explainer, I hope. At least that's my goal when I do this stuff. But it means that what I love to do is go out on adventures and ask questions and then figure out what it all means and try to explain it to you. And because I write about science mainly these days, it means I hang out a lot with scientists. I go on trips with them around the world. And so a few years ago, I became fascinated with figuring out how the ocean works. I didn't know anything about it. I mean, I grew up on the prairies, and I just became fascinated with this. I had done a whole bunch of writing for the Globe and Mail about environmental issues. I was their Earth Sciences feature reporter for quite a few years. So I wrote about climate change and droughts and, people clear-cutting forests, and I wrote about animals' extinction. I remember going to Madagascar one time. It was my first really big overseas trip. I had never been below Europe at that point, and I begged and pleaded my way to Madagascar. And I remember being in this little tiny remnant of a forest in Madagascar, which is the most endangered land base we have in the world, and trying to find a lemur. I spent days and days and days trying to find a live lemur, and I finally went to this little tiny fragment of a forest, and I was only, I'm as far as Janice is away, maybe a little closer to this ring-tailed lemur, and I could see its little diamond-shaped pink tongue licking every finger on its hand like this, just as far as I am away from, a little closer than extraordinary experiences like that. It's been really quite fun. But I kept hearing about the ocean. I was in the middle of writing about all this stuff about the land. I kept hearing about the ocean. I kept hearing that it was dying, and that the fish were vanishing and all this kind of stuff. And I never had any real detail on it. And I'm kind of the kind of person who likes details, so I thought, okay, is it true? And if it's true, does it matter? Does it really matter? How can I know this? Does it matter to me? Does it matter to you? Does it matter to life on Earth? And so I launched on this quest. I started to read up, and this was several years ago now, and it was incredibly hard to find out information about the ocean. Scientists were looking at it, but they were looking at little pieces of it. So somebody would be looking at fish, somebody else would be looking at deep water vents, somebody would be looking at coastal zones, but you never had anybody looking at everything all together. And that's kind of what a journalist does. We're kind of like astronauts. We try to look at all the pieces and put them all together. And so that's what I started to doing, because nobody was talking about what it all meant. They were getting data points, but there was no meaning attached to that. And so I started to look at the data points and then try to put meaning to them. So here are a few data points. You probably already know them because I know you're extremely well versed in all of these issues, but 99% of the living space on the planet is in the ocean. So here I had been schlepping around the world writing about, the 1%, right? I had no concept of what was going on in the ocean. Every second breath you take is oxygen produced by plankton in the ocean, at least every second breath you take. The ocean controls most of the carbon cycle on the planet, much of the nitrogen cycle, obviously much of the oxygen cycle. These are the building blocks of life on the planet. Life began in the ocean. In fact, there was life only in the ocean for the first more than 3 billion years that there was life on the planet. We're latecomers to the planet, we terrestrial creatures. So, and of course, the ocean is a single interconnected system. It's not just the 7 seas. It's not one ocean that's not connected to the other. This is a system that all works together. So I started looking at all this stuff, and I thought, well, I have to go and find stuff out because I'm the daughter of a biologist, and so I go on journeys with scientists to try to figure out what's going on. So I found myself in Panama several years ago now, with this brilliant biologist, marine biologist named Nancy Knowlton, and she's a specialist in corals. And we were going off to watch a coral spawning. Do you guys know what a coral spawning is? So it's the once a year. Do we have any kids in the room? No. It's the once a year orgy that all these. It's like the reef has sex. It's just incredible. This incredible, orgasmic, few minutes of the ocean when all of these coral animals have sex all together at the same time. It's sort of the make or break moment for the year, and it's. And it's really uncommon. It's West Hill, I can say this. Right? It's really uncommon to be able to witness it, which scientists didn't even know until, a few decades ago, that this was how they reproduced it. It had been one of these great mysteries of, for a long time. Anyway, so it's sort of like winning a lottery if you're a scientist to go and see this. But if you're a journalist to see this, it's incredibly rare. So, I said to Nancy, how do these guys know when to do it? I mean, they have only a single orifice. They're only a few cells deep. They don't even have a brain, right? How do they know that this is the one moment? And she said, well, we're not quite sure, but it has something to do with the alignment of the Earth, the Sun, and the Moon. And somehow they read these signals, and so they do this. And she said, so the ones we're going to watch in this coast off Panama, these guys should spawn at about 100 minutes after sunset, after the last full moon of summer. About 6 days after the last full moon of summer, 100 minutes after sunset. And it was just this incredible, how do they actually know this? And so night after night, and you can imagine there's this team of scientists from all over the world, and I'm not a scientist, and I don't scuba dive. At least I didn't at that point. So I'm hanging up over top this ocean. It's nighttime. There's this team of scientists underneath me, with their little flashlights, peering at these huge, big coral reefs, peering into these little orifices to see if these guys are getting ready to go for it. Night after night after night, and night after night after night, there's nothing, and I'm hanging on top, with this snorkel mask that doesn't fit, and I'm wearing somebody's borrowed T-shirt because, of course, I've never done this stuff before. I know nothing about the ocean, and I'm waiting to see what happens. So on day 6, we get in the ocean just after sunset, and we know for sure that tonight is the night. It's just, there's all of this sexual energy, and it's just coursing through the reef, and it flows through into our bodies, and we're just absolutely convinced. And so we get in there, and sure enough, at 100 minutes after sunset, these little pink bundles of egg and sperm start rising to the surface. And we capture these things, and it's this moment of exquisite hope. This is life. And we're witnessing it. And so we capture some of this little material and we take it back to the lab, and we stay up all night because we're going to count to see how healthy these things are and see how many reproduced. This is how you tell whether an ocean is healthy. And we're really excited. We're calling ourselves Team Spawn, we're really going for it. And it gets to be about 4 a.m, and we do the numbers. And the numbers tell us that only about a quarter of the corals that should have spawned that night did. And corals have been around on the planet in some form or another for about 500 million years. So maybe this was really great, but to us, sometimes it's 98%. Some years it's 98% of the corals that spawn. So to us, it was absolutely devastating. It felt like it was death in the midst of this ritual of birth that we had come to witness. And so I said to Nancy, what's going on here? And she said, well, it's because the water is warm. And it's true, when we got in the water, we could see these big, on these big reefs, you could see this flesh sort of tearing off in strips. It was all white, as white as this page, tearing off in strips from the heat. These were corals that were dying, so they didn't have a lot of energy to, pump out the next generation. And I said, so why is the water so warm? And she said, well, We're burning fossil fuels. That's putting a load of carbon dioxide into the atmosphere. That's holding heat against the body of the planet. And that heat has to go somewhere. It goes into the water, warms up the water. And it's not just the Caribbean. In the Caribbean alone, something like 80% of the corals in the last 30 years have died off. And that's a bad situation, but it's similar around the world. So something like half of the corals species around the world are in pretty dire straits. And it just galvanized me. I mean, I was there in Panama with her. She's one of the great marine biologists in the world, and I thought, I have to know a lot more than this. So I launched myself on these journeys, 13 journeys in 3 years around the world. I spent a lot of time on boats. I don't like boats. I'm a kid from the prairies, let me tell you. So I want to tell you about 3 of those journeys, because 3 of them are what, I write about many of them in the book, Seasick, but 3 of them ended up being the most important and the ones that I think you'll want to know about the most. So the first one was to Plymouth, England. Anybody been to Plymouth? The great launching off point for Darwin, for example. And they joke in Plymouth that they have more marine biologists per square inch than anywhere else in the world. They just they just get there and stay there. So I'm in Plymouth and I'm running around doing all these interviews with scientists, because it's just a gold mine if you're a journalist. And one afternoon, I decided to take the afternoon off and go to the museum, the aquarium, which is up on the hill overlooking the Plymouth Sound. So I'm wandering around this aquarium, and you go in, and the thing about this aquarium that's so cool is that there's a plexiglass sheet that sort of goes up like this, and you're actually. You feel like you're in a tank, and it's called the Mediterranean tank, and above you are swimming all of these creatures from the Mediterranean, like barracudas and stuff like this. Except that today, and this thing, this grand new aquarium opened in 1998, and today they can't call it the Mediterranean tank anymore. Why? Why do you think? You can guess. Sorry? That's exactly right. The fish that used to live in the Mediterranean now live and breed in the Plymouth Sound. So they can't call it the Mediterranean tank, because they could as well call it the Plymouth tank. So you have baby barracudas in the Plymouth Sound. You have, and this whole phenomenon has happened all over the ocean. So you have these creatures that have fled from the heat of the Mediterranean, and some of them have made it all the way to Plymouth. Some of them have stopped on the coast of France. Some of them are heading up to Greenland. But if you live in the ocean, your neighbors are your food, right? This is how grocery stores work in the ocean. And when they disperse to different parts of the ocean as refugees from the heat, it means that the whole fabric of life is torn. And that same thing is happening all over the ocean, no matter where you go. So I'm thinking to myself, wow, so the ocean is getting warm. There's all this extra heat. It's not just the corals, it's all of these other creatures as well. So that's the first journey. The second journey was to the Gulf of Mexico. I went into the Gulf of Mexico to investigate this thing they call the blob. So the blob is a dead zone, meaning it has little or no oxygen in it. And I'm on a ship with a whole bunch of scientists, and they're investigating this thing. And one of them he was interested in getting some fish, this guy, Stu Ludson, his name was, and he wanted to catch some fish in the dead zone and take them up north. So to investigate them, see how they looked inside, what was happening to them physiologically. So he was putting his nets in night after night after night, day after day after day, at the bottom of the water column, at the middle, at the top, in this dead zone. And he was getting nothing. And he thought that there were holes in his nets. So finally he said, look, I've got to test these nets. We steered the ship out into part of the Gulf that still had oxygen in it. And this is a massive dead zone. This thing is the size of New Jersey. It's absolutely huge. It goes right from the bottom of the water column up to the top. So we drive the ship out into part of the water that still has oxygen in it. He throws his nets in, bam, they're full of fish, absolutely full. And so then he knows that it's not his nets, it's the oxygen. And so I'm sitting there thinking, why is there no oxygen? What happened to the oxygen in this huge swath of the Gulf of Mexico that should be teeming with life? And he says, well, it's the farmers up and down the Mississippi River. So the Mississippi is like an artery that runs through North America, filled with farmland. And on these farms, farmers are putting fertilizers, synthetic fertilizers, so that's phosphorus and nitrogen, right? And they're putting on so much that's flowing into the watershed, it's flowing into the Mississippi, and this thing, the Mississippi goes off like a faucet of chemicals into the Gulf of Mexico. But it's still food, it's fertilizer for plants, except now it's not corn and soybeans up the Mississippi. Now it's plankton, phytoplankton. And these things, this is the best all-you-can-eat buffet you could ever imagine, right? These plankton go absolutely crazy. They reproduce like mad. They make these huge algal blooms, but there's nothing to eat them. And so they die, they fall to the bottom of the water column, and then the second part of the process takes over, which is that bacteria start to decompose all of these little plankton. And as they decompose, they use up the oxygen. And so from this one little spot on the seabed floor at the mouth of the Mississippi River in the Gulf of Mexico spreads this dead zone all along the bottom, sucking the breath out of the water. And so everything that's there either dies or has to move. That's how the phenomenon works. And it spreads like this, right to the top of the water column in some places. And it disappears every spring, every fall, and it comes back every spring when farmers put more and more fertilizers on their crops. And the thing about it is that it's not the only one, right? When I started doing the research on this, I remember that there was a big news flash a few years ago when there were 150 of these dead zones in coastal waters around the world. This was really huge, serious news. Well, today there are 480 in coastal zones around the world. And 3 of them are really weird. 3 of them are not caused by an influx of chemicals into the water. 3 of them are caused by changes to the water itself. So instead of chemicals flowing in, what happens is that the currents are different, the temperature of the water is different, and that makes food, nutrients from the bottom of the water column come up, and you get the same phenomenon, an algal bloom that causes a dead zone. So these 3 huge dead zones, there's one off the coast of Oregon, 2 off the coast of Australia, of Africa, and they're really worried. They're really worried, scientists are, about those 3 zones, because why would they be so worried about those 3, do you think? They can't fix them, and they don't know where they're going to come up next. They don't know where they're going to spread. They don't know how far they're going to spread. Like the other ones, they sort of have a plan. The one in the Gulf of Mexico, they have a plan for how to make it shrink. They're not doing it, but they have a plan. They know, how that would work. But these others, they're mysterious. They're unexpected. They're surprises, and so it's very hard to know what to do about them. So that's the water's becoming breathless, right? The ocean. That's the second one. So the third one is maybe the most important. Wendy, where is she, Wendy? Wendy and I were talking about it just before I came in here. So the third journey involved my going to Puerto Rico to meet with a scientist named Joni Kleypas, who's one of the world's experts on this growing, interesting phenomenon called ocean acidification. There have been just sort of these murmurs in the scientific community about it, and this was a few years ago, and there wasn't really a lot of discourse about it. So she's an American government scientist, she was going to Puerto Rico to try to explain to her colleagues, marine biologists, what ocean acidification is. And so we're in a room, and she's explaining that what happens is that when we burn fossil fuels, fossils are they're fossils of animals and plants that lived millions of years ago. And, when they died, the carbon in their body was stored into the body of the earth. So when we dig them up and burn them, we're putting carbon from an ancient era into today's atmosphere. And we all know about that. We know about climate change and all that stuff. But what happens is that some of it stays in the atmosphere, some of it gets reabsorbed into plants and soils, and some of it gets absorbed into the ocean. But when it gets absorbed into the ocean, it chemically, it reacts with water to make carbonic acid, is the issue. And all these scientists in this room knew about this stuff. This phenomenon is well described in the scientific literature. But they couldn't understand that it could make a difference, because they figured there's so much water, this huge, vast global ocean, how could it make any difference? And what Joni told them is that, in fact, it's making an enormous difference. Already, the ocean is 30% more acidic than it was before we started burning fossils, so in about 250 years. And it's getting more and more acidic. The more carbon dioxide that goes into the atmosphere, the more the ocean becomes acidic. And And we got out of the room, and I said to her, but why does it matter if the ocean is acidic? And she said, well, it matters because of shells and bones and teeth. So effectively, what happens is that, when the ocean becomes more acidic, it means that there are more hydrogen ions on the loose. That's chemically what it means. There are all these little hydrogen ions that want to hook up with something. So the more acidic something is, the more hydrogen ions there are. And that's what's happening in the ocean due to this chemical change. But these hydrogen ions want to hook up with something, and the easiest thing for them to hook up to is the stuff that makes up bones and teeth and shells in the ocean, calcium carbonate. So they just erode it. They just take they hook up with it. And that phenomenon is happening. So at some point, already the ocean is pretty acidic, and there are creatures that are being quite badly harmed by it. But over time, creatures won't be able to make their shells and their bones and their teeth. And eventually, the ocean will become so acidic, those hydrogen ions will become so ferociously predatory that they will dissolve all of the bones and teeth and shells that are already in the ocean. And you can already see some examples of this in small creatures. Young creatures are very badly affected. So you have scallop embryos and oyster embryos that can't withstand the acidity in the ocean now because it's so much more acidic. And I remember hearing one account of a baby octopus that actually was climbing up a fisherman's line to escape the acidity of the sea. So that same phenomenon is happening right across the ocean, more acidic in the colder waters of the Arctic and the Antarctic, but it's a phenomenon that's happening all over the place. So I'm putting these pieces together. I'm really, I'm a journalist, right? I'm not a scientist. I'm just wandering around the world trying to understand how the ocean works, and I'm hearing all these tales of what sounds to me like pretty rough stuff, right? I mean, I'm standing there sort of putting all these pieces together in my head and thinking it all revolves around carbon, and what it really means is that the ocean is becoming warm, breathless, and sour all at the same time. So because I think about things in historical terms, I went to some scientists and said, so what has happened at other times when the ocean has become in the planet's 4.5 billion year history? When has it ever been like this before? Because there must have been times. The planet is an archive of its own history. And they said, well, it's only happened a few other times. And it's only ever happened when we've had mass extinctions. So there have only been 5 mass extinctions in the whole history of the planet. The one we know about is the one that, the best is the one that killed off the dinosaurs 65 million years ago. But in every case, in each of those 5 mass extinctions, the trigger for the killing mechanism has been that there has been a change in the concentration of carbon dioxide in the atmosphere, and therefore in the chemistry of the ocean. And the one that is probably the closest parallel to today that the scientists talk about is the Permian extinction, which happened 450 million years ago, and 95% of the species on the planet went extinct at that time. 250 million years ago, and 95% of the species on the planet went extinct in that same spasm of extinction. It would happen because there was a huge amount of volcanic activity that put a whole bunch of carbon dioxide into the atmosphere, and that in turn turned the ocean warm, breathless, and sour. So 95% of the species on the planet went extinct very, very, very rapidly if you think about the Earth's history. So then I thought to myself, so how quickly are we putting carbon dioxide into the atmosphere compared to then? So I went to talk to some more scientists, and they said, well, actually today we're putting carbon dioxide into the atmosphere at between 35 and 350 times faster than during the Permian extinction, which was the most severe extinction spasm in the planet's history. So this is quicker. It's not as prolonged, but it's quicker than, so far it's not as prolonged. It's quicker than during the Permian extinction. And this is like, I mean, I am a journalist. I am not prepared for this kind of catastrophe, right? I was innocently wandering the planet looking at some work that scientists are doing, and all of a sudden I get this picture of absolute mass destruction. And it's happening faster. It's like there's no plan to stop it. I'm looking around, and so, of course, what I did was fall into a very, very severe depression. All these pieces started fitting into place for me, and I went to bed for a month. and I'm supposed to be writing this book, right? And I'm thinking to myself, I'm not killing any more trees by writing a book. That's not going to happen. At least they suck some of that carbon out of the atmosphere. Anyway, I finally, I had one other journey left, and I think it's too ribald to tell you here in the church, even for me, but it involved going to the bottom of the ocean in a submersible with a fellow who looked very, very strongly like the actor George Clooney. And being down there anyway, I was down there for 3 hours in the deepest part of this, 3,000 feet below the surface of the ocean, and for 3 hours in the cold and the dark. And I had an epiphany there, which I write about a little bit in the book, but I tell a lot about in my play. And the epiphany essentially led me to think about what we do with all this data. So you have these data points, and how do you make meaning of them? What do you actually do about them? So the question is not what the information shows. The question becomes, what do you do with that information? What is the story you tell about it? And so I started thinking about the story that we're telling about the climate and the ocean. And I mean, that story is shifting, and we're just now at the end of Climate Week. And the UN is really taking notice of this, and we've had more, strong statements from the US president than we've had ever, and more strong statements from most world leaders than we've had in about a generation, I would think. We've had people marching in the streets, 300,000 people. A week ago today, marching in the streets of New York and marching all over the world to try to make people take action. But I think that underpinning that is a lot of blame, a lot of anger, and a lot of fear, a lot of which is justified. But I think there's a lot of finger pointing, and I think there's a lot of shame underneath all of that. That's the narrative we're telling each other, and I think that despite some of these outbursts of activity, that's still the theme, and that's really what I want to talk to you about. And I've noticed, for example, a similar theme in the church, that it's all over, that it's a dying cause. That's why I was so interested to come and talk to you here today. There's this narrative that we failed, that there's nothing to be done, we can't think of a way to move forward, and it nails us to the floor. Like that kind of guilt and shame, those strong emotions are incredibly powerful and incredibly paralyzing, I think. And so I started thinking about, and I don't know what the answer is at all to all of this stuff, but I think it has its roots in something deeply, deeply unfashionable, which is, I believe, forgiveness. And so one of the things that I had to try to explore with myself was how I could forgive myself for what I had done. I mean, all those planes, all those taxis, the way I live my life. All I have to do, in fact, to contribute to this problem is get up in the morning and turn on my coffee maker, or make dinner for my kids, and I'm contributing to the load in the atmosphere. It's not like you can avoid doing harm very easily in this case. And so I think the thing to focus on for me that I hope that I can focus on is this really radical idea of forgiveness, of forgiving ourselves and our species and each other, and giving up the blame and the guilt and the anger, and just moving on to make something better, shedding the blame and trying to use that power that we free up, transforming it into something, almost alchemically transforming it into something that will let us move on and make something better. So that's what I'm leaving you with today. Thank you.